Hi everyone. In this given problem statement, we are given a triangle array. We have to return the minimum path sum from top to bottom. For each step, you may move to an adjacent number of rows below. More formally, you are on the index I of the current row. You can decide to move either I index or I plus 1 on the next row. So here, right, let us take this example of 2. The value, right, would be below. The values are 3 and 4. Below that, the values are 6, 5, and 7. And below that, the values are 4, 1, 8, and 3. So here, right, if you can understand, right, the ith row, the 0th row, right, has 1, the second one has 2 values, the third one has 3, and the fourth one has 4 values. So from 2, right, I can move in 2 direction. I can either move to 3 or I can move to 4. From 3, I can either move to 6 or I can move to 5. From 4, I can either move to 5 or I can move to 7. From 6, I can move to 4, I can move to 1. From 5, I can move to 1, I can move to 8. From 7, again 8 and 3. If you look at it, right, it's like a modified tree, right? It looks like it, and we are going to think like it's a modified tree. So here, right, we have to find out what would be the best possible way of going. So right here we have been given, right, a follow-up question. Can we solve it using big of n extra space? So using recursion, that might not be possible. So you have to solve this problem using a tabulation method. So here, right, initially I have already redrawn the entire diagram for you to easily understand. And here, right, let's say I'm going to create an array and initial values are going to be all 0. Now, we already are aware that the 0, right? So initially, right, how this is going to work, which would be the most smallest one, right? So the idea itself is pretty straightforward or intuitive in a way. So I have to solve this in big O of n, or you can say, right, there would be number of rows. So let's say n cross m means total number of elements, I could say, and the space is big O of n, and how to solve it, right? So that is the question. Now we already are aware of the formula. Let's say dp of the ith row is going to be equal to the current, let's say, array of I, the current value, plus the minimum of, so it can move either in I index and I plus 1 index. So I can say dp of I comma dp of I plus 1. So how is it going to look? So let's say the 4 value, right, initial dp is this. So I can say, right, what would be the value of 4? So it would be 4 plus whatever the previous values are. So the previous values are 0 and 0, so it will remain 4. Similarly, the 1, right, it would be 1 plus the previous index value of 0 and 0. 8 would be same and 3 would be same. Now the question is, what would be the value of 6? What would be updated value of 6, right? And what we're going to do, right, we're going to store this into our dp. So now after our first iteration, the dp would be 4, 1, 8, and 3. Now we are going to compare, right? Instead of comparing it with this one, we're going to compare with dp. So value of 6, right, it would be 6 plus minimum of 4 or 1. So we know, right, the value would be 1. So I am going to store, instead of this 6, I am going to store 7 out here. What would be the value of 5? So if it would be 5 plus minimum of 1 and 8. So in this TP, right, I'm going to store 6. What would be the value of 7? It would be 7 plus minimum of 8 and 3. So obviously I'm going to store 10 out here. Now we are going to compare 3 with 7, 6 and 10 because you're going to store it, right? So it would be 3 plus minimum of 7 and 6. So if it's 7 and 6, right, it is going to come as 9. So 9 we are going to store, and 4. It would be 4 plus minimum of 6 and 10. Don't get confused with this one, right? Because instead of this, we are going to compare with this array or this TP value that we are storing. And this is going to be 5 index, but the one on the later on stage, right, that wouldn't matter. We are going to only compare it. So now 4 with our 6 and 10. So it will become, for a minimum of 6 and 10, obviously it would be 6. So value would be 10. And then 2, we are going to compare with 9 and 10. So 2 plus minimum of 9 and 10, we are going to get 11. So the result, right, we are going to say return whatever value would be stored at dp of 0, and this is going to be our output. And as I have already said, right, the time complexity of it is going to be big O of n representing the total number of elements, and the space would be requiring big O of n plus 1 because we need an extra space to calculate. So we would require one more extra specifier to be very, very accurate. But yeah, it's going to be a pretty efficient solution. Now let us jump to the Python solution. So the first thing that we need to do, right, we need to find our n. So n is going to be the last element, right, because the maximum number of elements is going to be stored in the last row. So I can say length of triangle, and here I can take the last row. So to get the n, now I'm going to create a dp. It means it can be an any array, right? And I'm going to say initialize it 0 multiplied by n plus 1. Once that is done, right, what I'm going to do, I am going to reverse it, because if you remember, right, when we are calculating, right, so you are first adding for the last row with our 0, then we're keeping on incrementing, right? So let us reverse it. So I can say triangle equal to triangle and reverse it. So if I print it, right, it's going to look something like that. It would be an inverted one right now. So triangle. So it would become an inverted triangle. Let me run it. As you could see, it got inverted. So basically, right, the row which contains the most elements is at the top. Now what I'm going to do, I'm going to loop through it. So I can say for try in triangle, and here, right, we are going to get, let's say for the first one, right, we are going to get this nested one 4183. So I can say for, and here I have to get the index and value. So I can say for I in range of 0 to length of our try. So the current value is going to be dp of I is going to be whatever value that is present in try plus minimum of dp of I or dp of I plus 1, as you have already said. Once that is done, right, I can simply return my dp of 0 and let me run the code. It should work unless there are some spelling errors. As you could see, it got accepted. Let me remove the print statement. It's not necessary anymore. And let me submit the code. As you could see, it got submitted. And because we are kind of running this entire solution in linear time, right? So our code is pretty efficient and we are just using big O of n space. Let me submit it again. I think it should be more than 90%. So it's pretty efficient in that regard. So that's all for this video. See you in the next one.